This is the office hours video for section 7, unit analysis. Unit analysis is a technique that a lot of people like to try to use, and it can be very useful. But a word of caution, unit analysis basically can only tell you if something is incorrect. It can never tell you if something is correct. So it's a way of eliminating incorrect answers. So it would never be the primary way of solving a problem. You would never want to use unit analysis to try to get the answer. What you would use it for is to check an answer. So checking answers is what unit analysis is for. And what I thought I would try doing is looking at the Now You Try It exercise from section 7 to determine which of the following equations listed there are 4 of them, is incorrect by unit analysis. So notice the question is asking which one is incorrect, not which one is correct. So if I look at the first one, which is labeled A, it's listed as 1 divided by the speed, which has a symbol V, is equal to the elapsed time divided by the horizontal distance. So if you wanted to check this, what you could do is put in the units for those quantities. The units in the metric system for speed are meters per second, and for time are seconds, and for distance are meters. So if you have 1 divided by a fraction, 1 divided by meters per second, what you can do is take the fraction in the denominator and flip it upside down. So when you do that, on the left-hand side, you get seconds per meter. So by putting in the units, we end up with this equation. This is called a unit equation, as opposed to a quantity equation. And while I'm mentioning it, let me just remind you that quantity equations are far superior to unit equations, because a quantity is something that is fixed by the structure of the universe, and units are arbitrary when created by humans. But in unit analysis, you would end up with a unit equation. And so what this unit equation tells us, since it's true, is that this equation might be correct. It doesn't tell us that it's definitely correct, only that it might be correct. We haven't eliminated it just on the basis of units alone. If we look at the second one, equation B, the distance is equal to speed divided by the elapsed time. So that's the quantity equation. Over here, what I've listed are the quantity equations. And it's important to recognize which are which symbols stand for quantities and which symbols stand for units. And sometimes they're the same, so you have to know by the context what kind of equation you're dealing with. It's also important never to mix these. Don't mix them together, part unit, part quantity. So let's see, the units of distance are meters. I'll put that there. The units of speed are meters per second, and the units of time are seconds. So I need to resolve this. When you divide by seconds, you can take that and flip it upside down. So seconds flipped upside down would be 1 over seconds. And multiply that by meters per second. So what we end up with is that meters equal meters per second squared. So you can see that that is not true. That is not a true unit equation. Meters are not equal to meters per second squared. So if I work backwards, since it's incorrect, I can say that equation B is incorrect. Again, notice that we can't tell whether an equation is correct or not. We can only tell whether it's incorrect. So if we look at C, equation C, the elapsed time, delta t, is equal to the distance divided by the speed. So if we put in the units there, distance is meters, and speed is meters per second. So if I take that fraction in the denominator and flip it upside down, it becomes seconds per meter, and multiply that by meters. The meters cancel, so I end up with seconds equals seconds. And so what this tells us is that that equation, that quantity equation, delta t equals delta x over v, might be true. It's certainly not incorrect due to units. Here's the last one. So the distance equals the speed times the elapsed time. Now you might know this from previous studies as distance equals rate times time. Does that look familiar? It might look familiar to some of you. So if we put in the units meters for distance, meters per second for speed, seconds for time, you can see the seconds cancel and you get meters equal meters. So by unit analysis, this equation is not incorrect. But again, we still don't know about these three. We still don't know whether equations A, C, and D, whether they're correct or incorrect. The only one that we were definitively able to determine was that B was incorrect. So again, I need to stress this as much as possible, that unit analysis can only tell you if something is incorrect. It can never help you figure out if it's correct. So don't use unit analysis as your primary way of solving problems. It's really only good for checking an answer when you're done using some other technique. So be wary of that. Very good.